In this video we're going to look at the RFeye site data archive system, which allows us to query information from the RFeye map database. The RFeye map database system has information put into it from mobile or fixed RFeye nodes, collecting information to local storage or streaming it over cellular connections. This information is processed and then put into the RFeye map database. The RFeye map database is a client-server system, so the database has a server which we can query using RFeye site as a client. So let's do that here. Let's put in a data archive. Let's just display the map for now. Finish. Here we've got the map brought up. This is a standard RFeye site map. So we have all the elevation data we can overlay into this, all the live information from live networks, so we can have live networks and archive information overlaid on each other. So let's start a connection to the server. So in this case the RFeye map server is on this machine. It could be anywhere in the world. We just type in an IP address or a host name here over this port, we can connect to that server. So let's start that server. So it's asking for which data archive we want to go and look at. So I'm going to look at data archive called map process data. The system creates the connection to the RFeye map server, and now we have a connection. We can start querying what data sets are on that server. So let's load the dataset info. So we have an archive called test archive 1, which I created earlier. It's 5 gigabytes. We can load the data threads. This is the various information within that data archive here. So we've got scans from 100 megs to 3 gigs, and some more detailed scans from 900 megs to 900 megahertz to 960 megahertz, and there's different processing we've had on those. And we can look at how many units collected that data. So in this case, this data archive was created just using one RFeye node with this name. This could be any name, but we usually put the host name into the file of the RFeye system which collected it. So that's all well and good. So we can take a look at some information we want to analyze. So let's just take a closer look at the 900 to 960 meg band. So we don't really need to have this information in there. We just want these 3 data threads loaded in. We'll force a query to that band. We'll go over to look at the query. So we can see the query's been set up. We've got peak processing on. I'll explain more about that later. And then we can load all data into a map region, which is, we click on here. So now we can go and see we've started to get some information here displayed on the map. What I'll do is I'll just allow us to highlight the start of the data over the background, so we can start seeing what has actually been loaded. So what we've said is, from the data archive we want 1,000 data points loaded. So this represents 1,000 data points, and each one of these squares is aggregated data. So this square is showing peak power, so color is power, so red is high power, blue is low power. We look on the results section, we can show that power scale here. And then with this 1,000 points we can start doing some analysis. So what we want to do is set the query region. So we've got 2 regions here. So this means we can limit the amount of database. So if this database was this data archive was several terabytes, then we don't want all that data loading in. So what we've said is, this is the selection region, and then this is the query region. So I want to load all data in within this region, but I just want to query the data within this region. So if I load that data, I only get this data, and then I can, instead of taking 1,000 points, I can load many more points. So I can, if I select -1, I will load all the points within this region. See, we're loading from a database now, and now we get all the trails, all the data points from all the information collected as we've been moving around using the mobile data collection system. So if we take a look at results, we can say, well, this is at the data points only. We can actually put a tile system on there, so it's much easier to look at and aggregate information from those tiles. So at the moment those tiles are processing on peak information, and we've got 20 tiles by 20 tiles. I can change the number of tiles on the X and Y axis, and then I can change the processing in there from mean to minimum. Then if I want to look at more data, I can expand the data selection region, go back to the query and load that data. So now we're loading all the data we have in this region. And we'll look at how many points that is. So now this is all the data loaded and it's been tiled. And then we can take a look at the results, do the processing on there. We can also just show the set summary. So in this case we've loaded 34,000 spectral points, and we're doing peak processing on those points to overlay that information across a large geographic area. And then we can output this information to KML, JPEGs, PNGs, save all the results to CSV, so it can be imported into other people's systems. But this gives a general overview of how the RFeye map data archive system works and the tools we use to access that client server system. So let's look at some more charts which we can put on. So let's look at plots, and let's put on a 2D waterfall. And let's load the data into that waterfall. So what we're going to see here is, as we load the data into waterfall, we get a cross correlation between information, and again this is a standard CRFS waterfall. We get a correlation between the point I'm analyzing in the waterfall, and that's cross-referencing it onto the map to where that data point was collected. So we can see that by the green line, and I can also do it on the green line here. I can go to a point on the map and it cross-references to a point in the waterfall. I can do that with my spectral plots also. Let's just change that, maybe change that line to white, just make it a bit more clear. There we go. And we can see how we're jumping between the points on the waterfall, or we can jump between the points on the map depending on which one we're driving. That's a basic overview for RFeye map. There'll be more in the series of more advanced options and analysis we can do with RFeye map in the later videos.